Yeah, hello everyone. So in this lecture, we will be starting hashing concept. So there will be series of all the data structure that we will be discussing. So we have taken hashing concept over here. So before understanding hashing, let's try to figure out like, what is the requirement why hashing is required. Okay, so let's see. There is two arrays. Let us suppose I will name this array A and this is the array B. Okay. Now there is some relation. What is the relation? That array A contains the value which is called as a key, and array B contains the value, the data which is called as a value. Value of what? Value of array A. Okay. Now what is the value? How I can say? So see this table. So you can see that it is marked that a 7 is the key and 31 is the value. Okay. Similarly, 0 is the key, 33 is the value, 6 is the key, 45 is the value. So what is the relation that we will find? We can see. So you can see that key is that value. Key is that value which like which has the same index. So what I'm trying to say that at the index 0, whatever the value is present in array A will have the value, the value of that key will be the data that is present at index 0 in array B. So what I'm trying to say that key will be equal to A0 and value is equal to B0. Okay. So this is a relation. Okay. Now, what is our goal? So our next goal is to make this whole relationship into one array. How we can do that? So let's suppose I'm going to create one new array. 1, 2, 3, 4, 5, 6. Okay. So now let's give an index. So as we know that there is a relation with the index number. Okay. There is a relation with the index number. Okay. So let's give an index 0, 1, 2, 3, 4, 5, 6. Okay. Now let's make the indexes our key. Okay. What I'm trying to say that as we know there is a similarity. Okay. So what I'm trying to say that let's make index be our key. Okay. Index be our key, and whatever the value will present in this new array, let us suppose give this array name n. So whatever the value will present in this new array will be the value of the key. Okay. So let's see. Now let's fill up the value data over here. Okay. So 7. 7 is the 7 key has the value 31. So let's search 7 index. Okay. So at the 7 index will fill the value 31. Okay. Similarly, at the index 0 will fill 33. At the 6 will fill 45. At the index 4 will fill 9, and at the index 5 will fill 7. So now the question comes, these values will are unused. Okay. So yes, we have successfully merged those two arrays which had some relation. Let us suppose that relation is, we will be able to see that relation will be called as the hash function later on. But currently that there is a relation between the first and the second array, and we are able to successfully merge into one array. And the issue is that we have a lot of space wastage over here, right? And now, what is the space complexity? If we will see, the space complexity will be the order of 2n. So we are just doubling the value over here. Okay, like in this scenario. Okay, so now let's change our goal. Okay, like first goal that we successfully merged into it, but there was issue. The issue was that we were able to see a space wastage was happening over here. Okay, what was that? There was a space wastage. Okay, there was space wastage happening over here. Okay, so let's move our next goal. Our next goal to reduce the wastage. Okay, so let's reduce wastage. Okay, space wastage. Okay. So how we can reduce? Let's find one for kind of formula kind of things. Okay, so let us suppose how many values are there total in this. Total values are 1, 2, 3, 4, 5. Okay, total values are 5, right? Total values are 5. Okay, so let's have n is equal to 5. Okay, now what are the keys? Our keys are, let's do one more quick round, that our keys are this: 7 is 31, 0 is 33, 6 is 45, 4 is 9, and 5 is 7. Okay, let's make keys, let's make the let's make values to be, okay, let's keep it 5 only. We'll see. Okay, so what is 7 modulo 5? What is that? The value will be 2. You know what is modulo? The remainder. When we are going to divide 7, 5, 1, 5, 7 minus 2, 2. So our remainder will be 2. Okay. Similarly, let's do 0 modulus 5. 0 modulus 5 will be 0. Let's do 6 modulus 5. It will be 1. Let's do 4 modulus 5. It will be 4. Let's do 5 modulus 5. It will be 0. Okay. So this is something, a formula that we have generated. Okay. This is a formula that we have generated. Okay. What is that? We'll see. This is a formula that we have generated. So let's put those values in one array. Let's put those values in one array. So 0, 1, 2, 3, 3, 0, 1, 2, 3, 4. Okay. Let's keep the value. So now let's put the values uh, in this array. Let's give an array name as a k. Okay. Now, so we'll fill the value. So at index 2. So let's now, this is our new index. This is our new key that we will be marking at. So our key is 7, and we have added one function that we will be modeling. We will doing the modulus operator on our key, and whatever the value will be there, we'll store the key value in this array index. Let me reiterate that what after doing the modulus operation on the key, whatever the value we are going to get, that value will be the index where the key's value will be stored. Okay. So let's see. So now the 7 is the key. We divide, we do a modulus operator with the 5. The remainder we get 2. So 2 is our index. So this is our 2, and we'll fill the value 31 over here. Okay. Similarly, for the 0, we got the value 0. So on the 0, we'll fill the value 33. Similarly, for the 6, we got the index 1. At the index 1, we'll fill the value 45. Similarly, for 4, we got the value 4, and we'll fill the value 9. Now, there is one interesting part, that on the last value, this 5, on the last value, this 5, we can see that it has again received the index 0. What is trying to say that you have to insert 7 value again in the index 0. Now think, is it possible to store two values at the same index? Right? No, it is not possible. So this is not possible, but we have to do something like that. This is where we are now. We are moving towards hashing. Okay, this is where we are moving towards hashing. So here, this concept is something called as a collision. This concept is something called as a collision, right? Collision means what? Collision means whenever two keys have the same value, that is something called as a collision in hashing function. Okay, use those terms within the interview. Okay, so now, so within the hash function, what we did, we feed the key, get some values, and and it is not hard and fast that we have to use this formula only. We can use any other formulas as well. Okay, so let us suppose, if I give an example, you can create a hash function for this. There is a word. Okay, so for this hash function, if you want to create, so what you will do, I'm just creating a hash function. Will calculate the alphabetical numbers of it. So if you can see, for S I will take 19, for T alphabetical number I will take 20, for A I will take 1, and for R I will take 18, and however total sum is equal to 68. This is also one kind of hash function. Okay, so this depends as per the use case. Okay, so we are trying to understand what is hashing. So now here the collision has happened. So now the question comes. First of all thing is that within an array, within the same index, we can't store two values. So there should be another way. Yes, there is another way for to store two values with the same index. We'll see. Okay. So now the question comes, within the collision. Within the collision, is it possible to remove collision within the hashing? No, it is not possible to remove collision from hashing. It is not possible. Collision will be there. Collision will be there, and we cannot remove. But there is a chance we can decrease the collision. We can decrease the amount of collision. Okay. So now, now the question comes, when we are expecting that array will store the value 1 at least. Okay. So near about, when we calculate the time complexity to search any values, it will be near to O1, or the space complexity. Time complexity will be near to O1. Okay, to search that. Okay, so now let's move. What I'm trying to say, when we will have a two different two values at the same index. So let's redraw our array. Now we are going to draw an array in reverse order. In reverse order. Okay. So let us suppose I have this value. What was the value? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay. Now at the 0, we have two values, 33. 133 will be there, and one value will be stored like this, 7. Okay. Now then another values are 45 and 31. 45 31, and 3 was nothing there. With the 4 there was one value, that is 9. Okay, so this is something called hashing. Now the question comes, up to what length we will be doing this. Let us suppose we have a very large integer. Okay, and I'm taking let us suppose 7, 6, 5, 10, 15, 20, 30, 25, 3, 2, 1. Okay, let's do a mapping for that. Okay, so our n is 5 right now. Okay, so we will be doing modulus operator with 5. Okay, so second, yeah, let's try to do one thing. So let me take index. If we know the n is 5, so our index will be 0, 1, 2, 3, 4. Okay, now when we will be doing 7 modulus 5, what will the value? 2. Okay, so I will store 7 here. Now when I will be storing 6, the value will be modulus 6 modulus 5 will be 1. Okay, similar. Now when I will be doing 5 modulus 5, the value will be 0. 5 is there. When I will be doing 10 modulus 5, the value will be again 0. So what I will do? I will do 10. When I will be doing 15, again it will come into 0 index. When I will be doing 20, again it will come into 0 index. When I will be doing 30, again it will come into 0 index. When I will be doing 25, again it will come into 0 index. Now when I come to 3, 3 will come here. When I will go 2, 2 will come here. When I will go for 1, 1 will come here. Okay, so you can see that there is no control over this length, this whole length. There is no control. We don't have a control over here. Okay, so here comes a concept, something called as a load factor. What is this concept? This is a concept called as a load factor. Okay, what is the load factor? Load factor has a formula that n by b should be less than equal to 0.75. If this is not there, then you have to, if this condition is not satisfied, then you have to do what? Then you have to double the size of b and then again recalculate the value. So if when you do the double the size of b, then again you try to recalculate the value. If it is let's suppose if this was not satisfied, so that's why we did this. Now again we did the n by 225 0.75. Again let us suppose if it is again not less than 0.75, again you have to do what? You have to do again do this thing, 2 into again double the bucket size b, value of b. And what is b? I will tell you. So it will be n by now 4b less than equal to 0.7. If it is satisfied, then you are using a correct load factor, and this kind of situation will not occur, because there will be a 1 million data, there will be billions of data, and how you won't do like this, right? So that's why load factor comes into the picture. Okay, now the question comes, what is n? N is nothing but number of entries in the map. Number of entries in map. What is the number of entries? Entries means like include all the values. What means including all the values? That you will take this. You will take 5 also, 6, 7, 3, 10. So count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Total number of values were 11. Okay. So for this example, our n is 11. Okay, let's calculate b. B is nothing but this key, this value key that we have bucket. We call it as bucket. Okay, so the key is the hash function that we have created, the value that is going to be mapped on this basis. Okay, that is the key. So the bucket size is 4 here. What is the bucket size? 1, 2, 3, 4, 5. Okay, so bucket size of array is sorry, 5. Bucket size of array is 5 here. Okay, 0 we are not counting. So 1, 2, 3, 4, 5. So bucket size is our 5. Okay, so we'll do a math over here. Okay, so 11 by 5. What will happen? 5, 11, 5 to 10, 1.05. So that is our n by b is equal to 2.5. Is it near to 0.75? No, it is not near to 0.75. What we have to do? We have to double the size of bucket. Okay, so let's do a double the size of bucket. So what we have to do, as n by b is equal to 2.5 and it is not less than equal to 0.75. So we have to double the size of bucket. So what is the b? B is our 5. So new b will be equal to 2 into 5 is equal to 10. So let's recalculate the value. 11, n is our still 11. We are not going to change the value of n. So n is still 11 and b is our 10. Okay, so let's go. So our n by b is equal to what? 11 by 10 is equal to what? 1.1. Is it less than equal to 0.75? No, it is not. Still it is not. What we have to do? Again do the same thing. What we have to do? Increase the size of b by double it. Okay, so 2 into 10, that will be 20, right? What we have to do? And n is again our n is still our 11. Okay, so n by b is equal to what? 11 by 20. Okay, so now if you calculate that, it will be less than 0.55. So if we calculate it 0.55, it will come. So now this satisfies our condition. Here we have calculated the load factor. So now what we are going to do? Our B should be 20, N should be N is 11. Okay. So now our new data will look something like this. Okay. Let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, so let's give the index number over here. So index will be 0, 1. Let's make it large. 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And 0 is there, so that's why 20 is not coming. Okay. So let's now again let's recalculate the value. So what was our integer? So our integer was something like this. It's over here. Okay. So second. Sorry. Yeah. Okay. Yeah. Okay. Okay. So yeah. So now let's calculate the value again. What was the value? How we calculating the value? So we'll do what? We'll do 7 modulus 19 now this time. Earlier we were doing 5. Why? Because the total size of this was 5 at the time. Okay. Now we'll do with the 20. Sorry, it will be not 19. It will be 20. Okay. So now when we are going to 7 modulus 20, it will be what? Keep it over there. Okay. Now when we will be doing 7 modulus 20, it will be 7. Okay. Now the 7 will store here what? 7 will store here the value. Okay, 7 is here. Similarly, for the 6, where we are going to store 6? 6 modulus 20 is 6. So 6 will be stored here. Similarly, where will the 5 be stored? 5 modulus 20 is equal to 5. 5 will be stored here. Similarly, 10, where we are going to store? 10 modulus 20 is equal to nothing but 10. So 10 will be stored here. Now modulus 15 modulus 20 is what? 15. 15 will be stored over here. 20 modulus 20 is what? 20 modulus and 20 is 20 modulus and 20 is 0. Okay. So 20 modulus 20 it will store here. Now 30 modulus 20 is what? 10. Okay. 30 modulus 20 is what? 10. So it will be stored over here. So now 10 already value is there. So again one box will come and 30 will be stored over there. Now 25 modulus 20, it will become what? 5. Okay. So 25 will be stored over here. Similarly, where will be 3? 3 modulus 20 will be 3. So 3 will be stored over here. Similarly, 2 will be stored over here and 1 will be stored here. So now let's copy this what we calculated over here. Okay. Copy. Okay. So let's compare in this way only. Okay. So earlier, if you can see, I'm just dragging it. So you can see that which is being dragged. You can see the size. The 5 has a value 1, 2, 3, 4, 5. 5 values were stored at the index 0. The load was very high. But now if you see the load is very less. You can see the same value we have stored with very less load. Okay. So that's where hashing comes into the picture. So when you go to the lead code and we try to solve the problem, and if you see that the time getting exceeded, time limit crossed, like that of error. So in those scenarios, use hashing, you won't get that error. So now the question comes. So what is the drawback when we are using the hashing? The drawback is that it is consuming space. And yes, you have to be bare with that. Why? It is something in convention is that on the place of time and on the place of a space, the priority is always given to a time and less priority is given to a space. So the company or an organization can bear the space issue with their system, but they can't bear time issue with the system. So if the system is lag, if there is a lag into the system, that is not acceptable. But if their system is very fast and there are some space which is not getting used, they can bear with that. Okay, so within those two options, if you have to choose, we have to go with the time optimization. Okay, so the time optimization happen, and you can see that how many times you have to do this load increase. So this load increase is doing it is very fast calculation. If you see, let's suppose 2, you are doubling the values. Okay, so earlier our value was 5, we double this to 10, first step. Then what did we did? 10 into 2, that is second step. Then 20 to 2, that is 40. Okay, third step, 40 to 2, that is what? 80. Fourth step, 80 to 2, what? 160 steps. Okay, the fifth step, sorry, 160 space came into the picture. Okay, then 160 into 2, now see, 320, sixth step. Now 320 into 2, what? 640, seventh step. And 640 into 2, what? 1280, eighth step. And 1280 into 2, 0, 6, 5, 2, 2, 5, 6. See, you can see in only 9 steps you have to perform, and you were able to increase the load, right? And it is taking very less time. If you go very serially to reach this 2560 number, there will be time complexity will be very high. But if you go with this hash logic, time complexity will be very less. And that's why hashing comes into the picture. In the part 1, this is all we have discussed. And make sure this hashing function is not fixed. You can have your own hash function. Like